What's going on, you guys? Mr. Allen here, and it might not look like it, but I'm here with some rational functions, and we're going to try to write a possible function to match each one of these graphs. Now, at first glance, this is the only one that really looks like a rational function to me. We got a vertical asymptote, horizontal asymptote, but if you look closely, I've got holes on the other three graphs. Rational functions have holes. All right, so this first one here looks like a quadratic function, right? And it looks like the function x squared minus 4. Okay, I'm gonna jot that down, all right? So let's call this f of x equals x squared minus 4. How did I come up with that? Well, my vertex was at 0, -4. So I basically took a quadratic that would be at the origin, x squared, shifted it down 4. And I can see with these other points, up 1 over 1, up 3 over 1, the same on the other side. So that is indicative of an x squared, your parent function, but it's just been shifted down 4. But I have this hole when x equals 0. So if I threw an x in the numerator and denominator, which would cancel, that would give me a hole at x equals 0. And if I plugged 0 back into its simplified form, right, if you think like ahead a little bit, like let's say this is my final answer here, but if I were to cancel those out, I'd be left with x squared minus 4. And if I plug 0 in, 0 squared minus 4 equals -4. I'd get that ordered pair of 0, -4. So there we go, guys. That is a possible function for this particular graph. Now, would you necessarily be producing these on your own? It's a good multiple choice question, honestly, where you could throw some graphs that maybe you haven't really seen a whole lot of, but see if you can match an equation to that particular graph. So don't be intimidated if it's like, bro, how'd you come up with that out of the blue? It might be somewhere to match some stuff. You could plug in some ordered pairs. If I plug 2 in, I would get 0, right? 2 goes here, I'd get 2 squared, which is 4, minus 4 is 0, right? The x's had canceled, so I can check some things out, make sure things match up. Let's pop over to this one over here. So I've got myself just a line. Interesting. But I do have this hole. So let's start building a rational function. We'll call this one g of x, just to change it up. And when I see a hole on a graph, I throw that factor in the numerator and denominator. So x would have to be x minus 2 here, right? X minus 2. If that were to cancel, I get a hole at x equals +2, which is what's happening here. What else could I get? Well, I have an x-intercept here of +1. So what if I threw a factor in the numerator, x minus 1, extend that out a little bit, x minus 1, if I plugged 1 in, my function would equal 0, right? I get my x-intercepts from the numerator. Nice. There we go. I think that checks out. I've got a hole when x equals 2. Let's see here. If I were, go ahead a little bit, if I were to cancel those out and have just x minus 1 then, if I plug 2 in, I get 2 minus 1 equals +1, which is exactly what that ordered pair is there, right? 2, +1. Awesome. So that all works out. If I plugged in, say, 3 for x, I would end up getting 2. 3 minus 1 is 2, and so on and so forth, right? You can even see that the x minus 1, that's my y-intercept right there, right? Linear equation. So this looks like an equation of a line, but we just had a factor cancel out numerator and denominator. That's another way of thinking about it. Again, guys, you might not have to produce these on your own, but a good multiple choice question, okay? Next one here. We'll call it k of x. K of x. Let's see if I have enough room on this fraction line. I haven't had enough room over there. Had to extend it a bit. We'll see. So this one's a little more straightforward. I got a vertical asymptote of x equals +2. So x minus 2 should be present in my denominator and not canceled, right? Let's see here. I have x equals +1 for an x-intercept. So x minus 1 would have to be in the numerator for that to occur, right? And then let's see here. Do I need anything else? Well, right now, my horizontal asymptote would be y equals 1 because the degree in the numerator, the degree in the denominator match up. So that's good. Let's see here. If I plugged in, it looks like I got another point here. This point is 1, 2, 3, 2. If I plug 3 in here, do I end up getting 2? So 3 minus 1 is 2. 3 minus 2 is 1. 2 divided by 1 is 2. So that checks out. This checks out. This checks out. This checks out. That checks out. Everything checks out. I didn't even need this full fraction line. We'll just erase it, you know? There we go. We got k of x. Beautiful. All right, and then the last one here. Another linear equation looking thing, but with a hole. So it is rational, right? It has that discontinuity there, but looks like a line. Okay, so we're going to have f of x, or no, sorry, h, I, j, k. Let's go L. I don't know. We wouldn't do I. H. Anywho, I skipped over H. I don't know what alphabet. I'm just going with it. Whatever, man. L of X. There we go. All right, so L of X. Let's see here. I got X equals 1 is where the hole is occurring, right? So I know I need to have X minus 1 present in both the numerator and the denominator. Now, let's see what else we can have here. There's no vertical asymptote, so nothing else in the denominator, right? That's the same thing that happened up here. Really, we should just be left with like an equation of a line. So if you think about that, I'm going to not use my x-intercept because I can't tell exactly where that is. But if we think about the equation of a line, that's what needs to be left in my numerator. My y-intercept is 3, and my slope is down 2 over 1. Down 2 over 1. So if I threw this, negative 2x plus 3, that should check out. If this were to be canceled, the x minus 1 were to be canceled, I'd be left with negative 2x plus 3. Let's see if some points go in there. If I plug 0 in, I'm going to get 0 plus 3 is 3. If I plugged 2 in, I'd get negative 4 plus 3 is negative 1. There we go. Yeah. So that checks out. We got all 4 of them, man. That was interesting. Very interesting, especially in these 3. Pretty straightforward here. Something that you can make up yourself. I think these are more of a good multiple choice type question. Can you match a function given this graph? Focus on the hole. Focus on the x-intercept if it has a clear one, or the y-intercept, especially if it doesn't have a clear one. Right, and then we should be all Gucci, as they say. That's about it, dogs. I hope you have an absolutely fantastic, wonderful day. See you later.